So say you want to submit a pull request to OpenShift. What happens when you type git push and hit enter? Well, nothing happens. It's actually a click. You have to go out to the GitHub interface and submit a pull request first.
OpenShift is a platform for helping people focus on the part of their application that's useful to them or their business and forget the parts that are more mundane or have to do with infrastructure.
So OpenShift is essentially a flavor of Kubernetes. It is just more enterprise ready with added features, focus on security. More components are added to it as well, like Prometheus, Grafana, telemetry, and it uses Cryo, which is a container runtime tool to spin up all your containers and pods. So submitting to OpenShift for the first time was a bit nerve-wracking also again. Like it almost felt like my first PR that I ever opened. That was because OpenShift, it's a much bigger code base.
My first time submitting a pull request as an intern, I think terror may have been the first emotion. It was really intimidating, and the reviews I was getting were really in-depth. But looking back at it now, I can tell that the people giving me feedback were just excited to see me grow and fix my mistakes. At the time, though, daunting.
One thing to always do when you're about to open a new pull request is to look through their README documentation. Sometimes someone might have done something similar to what you might want to do, so you can always go through the code, try to understand, and code.
When you submit a PR, a new namespace is created in our CI OpenShift cluster.
So you start with your most recent payload, it picks up your changes, it injects it into it. So now your release payload incorporates what you have changed. Then it spins up a new cluster with that release payload with your changes in it and runs all the end-to-end tests on that. So you have a cluster that then spins up another cluster to run your test. So like cluster-ception, I guess.
All of the integration and end-to-end test suites are run against the cluster that was installed using your change.
So for each test, a new cluster is spinned up on that CI cluster. So for each PR, you're essentially spinning up 8 to 10 clusters.
Some of the feedback that the automation gives to a developer when they create a pull request is whether or not the changes they've made have the product working.
When a test fails in a pull request, no big deal. You get a big red X for a while.
They'll start to get alerts on their pull request and comments, and also in like a little box at the bottom. There, they'll get a link telling them an overview of what's happened, what tests were ran, which ones failed, and the logs from that test case, so that hopefully they can dig in and see what went wrong.
First thing to check for is if it's a flake, because flakes do happen here and there.
A flake is when a test doesn't do the same thing every time you run it.
And sometimes it's a timeout. If it's a timeout, you know automatically that something went wrong and it's not your fault. But if you have run the test at least, like I would say 3 or 4 times and it still keeps failing, something's going on with your code.
It is not a good feeling. But I have to say that it has happened to everyone.
You can check other PRs in the same repository, see if it's hitting them. Then it means a CI issue. Obviously, you can ping the people who have more experience with these tests or the people who actually wrote these tests. Once you get that form of back and forth help, usually it's better to do it on the GitHub PR.
Especially in OpenShift, it's all in GitHub. And it's all in public repositories, of course. Everything is open source.
And that way it's out there for people in future if they run into similar issues and they can see how it was fixed. So then you go back to your local environment. Once you know what the fix is, fix it up, push it again, and it triggers the test again. And hopefully this time it will actually pass.
Once everything's green, you'll see a list of green checks.
That tells the merge bot automatically that this is ready to merge.
Any other pull requests that are currently eligible for merge will be tested.
Clusters are spun up with your test release image.
What it does basically is it starts that, it snapshots your changes.
When we're taking a snapshot of all the available images and we're choosing what version of all 200 components we're testing, we're able to record that in a release artifact, and we're able to say all of these versions of all these images have been tested together.
Your PRs made it through the rough waters and finally arrived at the tranquil tide pool.
Tide looks at the ocean of available pull requests, and it scoops passing pull requests into little pools to notice when they're passing all their tests and they're actually ready to merge. And then it makes sure that all the tests are up to date. And not only is any one pull request up to date with the latest version it wants to merge into, but even together as a pool, they're all working together as well. And then Tide's able to merge either one or a couple, whichever ones are available from that pool.
So in the modern era of cloud native, you might think that QE is important, but it is, because it's easy to pull down an upstream project and run it today. But what about tomorrow when you need to upgrade it? When you need to upgrade it, you need to test that entire platform for the upgrade itself and test what will happen going from point A to point B. That's where QE comes in.
Our QE department then takes releases and they try to break them.
And then testing to see how that cluster heals afterwards, or whether it does in the first place.
They have a whole nother set of tests that really work our clusters.
And QE does huge rigorous testing on it, oftentimes where they catch things that we have missed.
QE also validates that bugs are fixed. When somebody notices something's not working correctly in their production environments, often that also is something that's difficult to reproduce. Whether it's depending on a lot of load being on the system, or maybe it's a very specific configuration, QE is able to validate that that's actually fixed when the developers are putting in their pull requests.
And if there are any issues there, then we get a Bugzilla opened. Developers are pinged, and then we go through, fix everything, again, push it in. Another release is created, QE verifies it, everything is good. They give it that look good to me, and I was like, yay, I got in my first PR to an actual OpenShift project.
So behind the scenes, the cluster operates with a defined state and an actual state. When the cluster admin wants to upgrade, they set the defined state to the next version of OpenShift, and then the cluster upgrades itself seamlessly.
It will tell you when an update is available. You can also set it up to automatically update for you as soon as a new update is available, or you can make it manual.
When a customer is looking at upgrading their cluster, they're looking at these bundles of releases, and they're able to look at exactly which ones have been tested with each other. They're able to look at something and say, these versions have been tested 100%. And the results that we got in CI will be 100% exactly the same as the results that you're going to get on your deployment.
So we've covered a lot of ground, but getting from hundreds of contributors with hundreds of repositories to a single set of images that you know will run in production in OpenShift takes a lot of sophistication in a CI/CD system.